And now if I render this out, let's go into the material here, just turn on the material display there. You can see that even if I scrub in the viewport, what's actually happening, you're getting an animation of the actual the bitmap. And that will actually happen at render time as well. Let's do a render time. And there you go, you can see the colors are moving around. Now that's simply being caused by the parameters of the bitmap being animated. You could do the same kind of animation with self-luminosity, with specular values, with any of the normal parameters in a material. And those would be picked up and they would be animated. So that's pretty cool. Now what you don't have is you don't have any sort of per particle control over that animation. So let me just show you that with these particles, they're being birthed from frame 0 to 15. So there is actually an age difference between these particles, but you'll notice that all those particles there were synced up. If we look at the operator, you can see that we don't have any option here for actually synchronizing this animation with the age of the particle or when it's entered the event or anything like that. So you can see that material static is generally not that useful for working with animated materials, which is pretty obvious really. That's why in the next operator, material dynamic, you have all these controls for working with animations and so forth in materials. So just to show again, if I scrub the timeline, there come our teapots in, and if I go into the material, which in this case is this one here, turn on material display, press play, you can see that doesn't actually update in the viewport. It won't actually animate to the bitmap, but at render time that will actually be animated. So if we press play on that, you can see it's you've got this animation taking place on the surface of the teapots. So again, the animated texture is being honored and it's been rendered, but again you haven't got any control over synchronizing that animation with the age of the teapots or when they entered the event or anything like that. So it's of limited use, and as I said, it's probably best tackled using the material dynamic operator. Now the next option we have is to assign a material ID. And for that we won't actually use this operator, we'll use this one here. Actually this was animated bitmap, sorry. We'll just go on to the next one here. There we go, which is multi-sub object material. We've assigned material IDs and we're showing them in the viewport. If you turn it off, you can see it'll just use the first material in the multi-sub object list. You can see it's red. We've gone through a little rainbow here: red, orange, yellow, green, cyan, blue, and purple. If we turn on show in viewport, you can actually see the different material IDs that have been applied. So let's quickly run through the options that we have here. The first option is to assign a single material ID to all your particles. So there you go, material ID 1, 2, 3, 4, or whatever, whichever one it is that you want to pick. So that's obviously useful when you've got a multi-sub object material that you want to pick one material from. The next option is to cycle through the IDs. And you can see I've got cycle turned on, and it uses this rate set of options here to define how often that material ID will actually change. Now you can see I've got it set at the moment to use per particle. What that will do is for every one particle it'll increment the material ID. So if I change that to 2, that means that for every 2 particles the ID will increment. If I change it to 3, it has to have 3 particles before it'll increment. 4, as you can see, 5, 6, and as we put the number up, the IDs become trapped down into the lower values here, 1 and 2, because we've only got I think it's 12 teapots visible here. So I'll just put that back down to 1. The second option is to increment the ID value on a per second basis. Now a per second basis is very sensitive to whatever frame rate system that you're using. So we're currently using NTSC here, and that uses an FPS of 30. So if we want to have, let's say, our particle IDs increment once per frame, we would have to use a value of 30. If we change to PAL, we would have to use a value of 25 because PAL uses a frame rate of 25. I'll just put that back to NTSC, cancel that. So you can see at the moment I've got it set to 30, which means that on every frame the particle ID value will actually increment. Obviously you can have multiple particles entering the event during one frame, so all of those particles will actually share a material ID. Let's say you had 400 particles entering an event in 1 second, then you're going to have clumps of, let's say 30 particles or whatever it is, that are going to have one ID on them, and then another group of 30 and another group of 30 and so on. Whereas if you use the per particle option, every single particle that comes into the event triggers the incrementing of this counter. When it reaches this value, it increments the material ID and assigns a new material ID. So that's using the cycle option. The next option is random, and that will actually just assign a random material ID to your objects. And you can see here you can define how many submaterials you have. So if we put that down to 1, it'll just use the one material. It basically is a choice of 1 or 1, which obviously isn't very random. If we put up to 2, you're given it a choice of 2 different numbers, either 1 or 2. 3, you can see you got a choice of 3, 4, 5, 6, and so on. With cycle, what the submaterial option does is it'll actually assign the material IDs all the way up to 7, and then it'll stick on the last material ID. You can see you've got a lot of purple teapots here, and purple is our last color, so it's actually stuck on that. But what you can actually do is you can turn on the loop value here, and that will actually then loop back to the first number. So again, you can cycle, and you can actually fix the cycle range. So we got a cycle of 1, which is obviously useless, it's just using 1. Cycle of 2, so you can cycle through the 2 values. 3, you can cycle through the 3. 4, and so on, same again. And when we get to 7, if we turn on the loop option here, you can see it's allowed to go back to 1 again, and it can cycle back through the 7 IDs that we have here and keep on assigning those round in a loop. So that's it for the material static operator. It's very simple. It's used for either assigning a static material, in other words a material that you don't want to animate. You do have the option of animating that material, but you don't have very much control over it. So as I said, if you want to animate materials, it's best to use the material dynamic operator rather than the material static operator. The second function of the operator is to assign material IDs, and as you can see, you've got quite a lot of flexibility in how you do that. Okay, so let's move on and have a look at the material dynamic operator.